Hey again, Pre-Calc students. Time for another online lesson. This is the last one in Chapter 4 on radical equations and inequalities. When you hear that word radical, you might think of any number of these type of visuals, as you can see here, all the way from political radicals to radical race cars to radicals in science. But of course, when we talk about radicals in mathematics, we're talking about these root signs. Typically a square root sign like this, although you'll see a couple problems that have cube roots and fourth roots and things like that. So anyway, when we solve something with a radical sign like this, our main objective, of course, is to figure out what x is, but we have to get rid of that radical sign somehow or other. And so usually our goal is to get that radical sign by itself. So for instance, in one like this, I would first of all start out by subtracting 3 on each side. So then I would have x minus 3 equals the square root of x minus 3, which seems a little bit odd. And of course, the way to rid ourselves of that radical sign is to actually square both sides. So I can write it like this. I'm going to square that right side, and then I'm also going to square the left side. And of course, the nice thing here then is that when you square a square root, it's kind of like tying your shoe and untying your shoe. You get just what's inside that square root. So the square root of x minus 3 squared will just be x minus 3. And then when you square this binomial over here, again, be careful. It's not just x squared plus 9. If you need to FOIL it out, feel free to do that. But this is going to end up to be x squared minus 6x plus 9. FOIL that out if you need to. Or remember the shortcut we have talked about when you square binomials. Anyway, now we'd like to get probably everything over on the left side. So I get x squared. I subtract another x over there, and I get minus 7x. And I'm going to add 3 to each side here, and I'll get plus 12 equals 0. And sure enough, there's my quadratic equation, which we've talked about earlier in this chapter. We can solve in a variety of ways. I always like to try to factor if I can, because that's usually a pretty nice way, and it looks like this might be a good one to factor. So I can put x here and x here. Let's see, I have a minus 7x and a plus 12, so I think this will work. Minus 4 minus 3. And I believe if you go through all the FOIL methods, that will indeed work. Now, in order to solve this, I set each part equal to 0, because when I am multiplying two separate items and they equal 0, well, that means either this one has to be 0 or this one has to be 0. So I'll set this equal to 0, and you can already see what the answers are. X equals 4 and x equals 3. Now, one thing you might want to do, though, when you get your answers, is go back to the original equation, make sure that neither of these answers make the original equation go bad. And by going bad, we would mean in a situation like this that we'd have the square root of a negative number. Now, we've had square roots of negative numbers when we've been finding roots in this chapter, but when I'm just solving an equation like this, we would not want square roots of negative numbers. Kind of confusing, but that's the way it is. But notice that if we do go ahead and put 4 back in the original equation, that one looks fine. Put 3 back in there, that's okay. We would have the square root of 0, but that's 0, and that would work out okay. So in this case, we're in a good shape. A nasty one right here, and I think you can see why this one might be a little bit worse. We have square roots on both sides. So for instance, right now, I'm in good shape because, as we said before, I can square each side, and so the left side is no problem. That's going to end up to be just plain x plus 1. However, the right side is another matter, because notice what we have. This is like squaring a binomial, and let's just talk about this a bit. So I would square my first item here, so that's going to be 1, easy enough. I could square my last item here. That's not too bad either. The square roots will just remove themselves, so that's 2x minus 12, excuse me. But my middle term, remember, on these binomials is always the first times the second times 2. So yuck, here's what I'm going to have as my middle term here. 2 times the square root of 2x minus 12. Not very pleasant, because I end up having another square root here. But anyway, let's just simplify this a bit, see what we can do. I still have that x plus 1 here. On this side, I'm going to have that 2 times the square root of 2x minus 12. I can put a couple numbers together. I have a plus 2x here, and then 1 minus 12 is negative 11. So I just have to go through this process again of trying to get this square root by itself, and then I'm going to have to square everything again. Alright, so let's think about that. If I subtract this 2x from each side, I think I'll get a negative x. And if I add 11 to each side, I'm going to get a plus 12. And then I'm going to have this 2 times stuff here. Oops. That should be a minus sign. So minus 12 like that. Alright, so here we go. I'm going to change colors here so you can see this a bit better perhaps. So again, I'm going to have to now square both sides to get rid of this square root sign. So on the left side, well, I'm going to end up with x squared. I'm going to end up with a plus 144. What's my middle term going to be? Well, my middle term is always this times 2. So negative 12x times 2 should give me negative 24x. Meanwhile, on the right side, when I square this, I can square the 2. That'll give me 4. And then I will get 2x minus 12 because that square root signs are eliminated there. Again, it's a little bit goofy with that 2 in there. I maybe could have divided by that perhaps, but whatever. So anyway, I'm going to get 8x minus 48 here, and still nothing changes much over here. I'm going to kind of run out of room, I can see here on this slide. So now if I get everything over on the left, I'll have x squared, subtract another 8x, and I'll have minus 32x, and add another 48, and I'll have 192, I believe, right? Equaling 0. Not a real pleasant problem here, it looks like. I'm going to try to factor this. It looks like if I have factors of 192 that are 8 apart, so let's see, 192 divided by, I don't know, we'll try that. I think maybe 24 and 8 might work. So if I factor this, it's going to be x minus 24 and x minus 8, strange numbers here, equaling 0. So then if I go ahead and set each of those equal to 0, I'm out of room here a bit. Looks like x would either be 24 or 8. Now again, I better maybe just go back and try each of these values here just to see if they work or not. If I put 24 back in my original problem, I get the square root of 25 is 5. Over here I'll get 48 minus 12, which is 36. But I think you can see this isn't going to work with 24, because the square root of 36 is 6. 6 plus 1 is 7. That's not the same as the square root of 25. So really, when I look at this, I'm going to have to eliminate the 24 one. That doesn't work, and it didn't really make anything go bad in the function. It just didn't work correctly. 8, however, I think you'll see will work. In the interest of time, I'm going to not test that one. So that's kind of a Bearcat problem. Watch out for those. Here then talks about inequalities, and with inequalities, same type of thing here. Again, I want to rid myself of this square root sign, so I'm going to square both sides. So I get 5x plus 4 less than or equal to 64. No problem there. I'll subtract 4 from each side. So 5x is less than 60. This works out pretty nice. X is less than or equal to 12. However, there's one more tricky part here. What do I know about this 5x plus 4? Well, as we said before, we want to make sure that 5x plus 4, that's the part inside the square root, we want to make sure that that's greater than or equal to 0. On these kind of problems, we don't want negative square roots. So then if I solve this, I get 5x is greater than or equal to negative 4, and x has to be greater than or equal to negative 4/5. So when I take a look at both of these cases here, they both have to be true. If I sketch this out on a number line, we're saying here that x would have to be less than or equal to 12, greater than or equal to negative 4/5. I might like to write my solution something like this, that x is between negative 4/5 and positive 12. Kind of a tough problem. You can solve it algebraically, but then you do have to kind of think about it graphically and also logically to make sure that it makes sense. All right, that's it for today. And instead of saying we'll see you in class, we'll see you somewhere. And hats off to Felix. Bye now.